Hi, in this series of videos, we're going to learn about the continuous probability distribution. Unlike the previous topic where we learned about the discrete probability distribution, where we could assign a probability for every specific value of a variable x, this would not be the case in this topic. A variable y that has a continuous probability distribution will have such a large number of possible values that the probability that one value occur or is observed is very, very, very small, infinitely small, that you can assume that it is equal to zero. That's why in a variable that has a continuous probability distribution, we're not going to find the probability of a specific value, but rather we're going to find the probability that this variable will assume a or will be within a range of values. Okay, so that's the main difference between this topic and the previous topic. So we're going to start this topic by learning a very, very important concept called the probability density function, which would be the basis for the calculation of all the cumulative probability or the continuous probability. We're going to see that in due time. And we're going to start with a graph that is very, very familiar with you, which is the histogram. And we're going to build on that to show that how a histogram, for example, can be seen as a probability density function. We're going to see that later on. Then we're going to spend most of the time in these videos talking about normal distribution. Why that? Because in research and in inferential statistics, it's very important that the variable has a normal distribution in order to make our conclusions. We're going to learn about that. This is a widely used distribution, the normal distribution. It's very important and it represents also the foundation for all the probabilities that we're going to use in future topics. So make sure that you understand very well the normal distribution, and once you learn it, once you understand how to find a probability within a certain range when it has a normal distribution, then you'll be very, very at ease in the future topics. Then we're going to talk about a very specific continuous distribution called the exponential distribution. It's a widely used one also, and I'm going to give you some examples when we come to that. And finally, I'm going to mention three other continuous distribution, but we're going to learn here only about one of them, which is the t-distribution, for reasons that also I will explain later why we want to cover that. Okay, so let's start. So as mentioned in my introduction, this is the definition of a variable that has a continuous probability distribution. Okay, so we call it a continuous random variable. It can assume a very large number of possible values that we say that it's uncountable. And even if you can count it, in fact, and it is very large, you can still consider this as being a continuous random variable. Why that? Because think always about assigning the probability for specific values, for individual values of this variable. Remember what was our main approach to assign probabilities. We use the relative frequency. So imagine a variable that can have, let's say, 2000 values. These are countable, right? You can count them, 2000. But think about it. Again, just for simplicity, assume that all the possible values have equal likelihood of occurrence. So what is the probability of every specific value? Using the relative frequency, it's equal to 1 over 2000. This is a very, very small value. that is approaching zero, right? And if you increase the number of these values, you can easily say then that the probability of an individual value is indeed zero. Okay, so that's why, as I said also in the introduction, in a variable that has a random or a continuous distribution, we do not look for probability of a specific value, but rather for probability that the variable can be within a certain range.